Hello, since I'm discussing about complex number, I solved two problems already in complex number. And the third one is given that 1 omega omega square are cube roots of unity or 1. So we have to find out this determinant value 1 omega to the power n omega to the power n omega to the power n 1 omega to the power n to the omega to the power 2n. Here omega to the power 2n omega to the power n 1. So we have to solve this. Let's take the question. 1 omega to the power n omega to the power 2 to the power n omega to the power 2n 1 omega to the power n omega to the power n omega to the power n 1. So I have to find out we have to find out the determinant solution. We know that omega cube is equal to 1. So we replace 1 by omega cube. And omega cube whole to the power n is 1 to the power n, which is also 1. This can be written down omega 3 to the power n. So we replace 1 by omega to the power 3n. Omega n omega to the power 2n omega to the power 2n omega to the power 3n omega to the power n omega to the power n omega to the power 2 to the power n omega to the power 3n. Now we will take common omega n from all the groups, and it will be omega n whole cube and the remaining are So you can sum, will not take common, we just sum R1, R2, R3 by operating this. So we'll take we operate R1 by R1 for C1 plus C2 plus C3, and we will have omega n plus omega 2n plus omega 3n omega n omega 2n, and here again will be omega n plus omega 2n plus omega 3n omega 2n omega n, and here only will be omega n omega 2n omega plus omega 3n omega to the power 2n omega to the power 3n. Now we will take common this omega n omega to the power n plus omega to the power n plus omega to the power 3n. We have omega n plus omega to the power n plus omega to the power 3n. And we will have 1 omega n omega 2 to the power n, here it will be omega to the power 2n omega n, and here it will be omega to the power 2n, this is 3n actually, this will be 3n 2n, and this will be omega 3n. Now we can subtract R3 from 1 and 2, then we will have 2 zeros in this way. So we have omega n plus omega 2 to the power n plus omega 3 to the power n, and the determinant will be 0 omega n minus omega to the power n omega 2n to the power 2n minus omega to the power 3n in this way. Then will be 0 omega to the power 3n minus omega to the power 2n omega to the power n minus omega to the power 3n 1 omega to the power 2n omega to the power 3n. So if we do, this will be plus minus plus minus plus minus plus minus plus. This is 3 1 plus, here it will be positive. So we have omega n omega to the power n omega to the power 2n plus omega to the power 3n, and here it will be omega n minus omega to the power 2n omega to the power n minus omega to the power 3n minus this 2 omega plus 3n minus omega to the power 2n omega to the power 2n minus omega to the power 3n. It is common. You can do in smaller form. This is in large one. You can do it in this way, given that omega 1, omega to the power 2n, omega to the power n, omega to the power n, 1, omega to the power 2n, omega to the power 2n, omega to the power n, 1. Now we can do the sum of R1 and C1, C2, C3, or we can sum R1 plus R2 plus R3. We will have 1 plus omega 2n plus 1 plus omega to the power n plus omega to the power 2n, and then 1 plus omega to the power n plus omega to the power 2n, omega to the power 2n, 1, omega to the power n, omega to the power n, omega to the power 2n, 1. And now to take common, this will be 1 plus omega to the power n plus omega to the power 2n, so we will have 1 omega to the power 2n, omega n, 1 omega to the power 2n, and here it will be 1 omega n, and here it will be 1. So we know that omega q is equal to 1 and 1 plus omega is equal to 0. So omega q, omega 1 plus omega is equal to 1 plus omega minus plus omega plus omega to the power 2n. Now we subtract the column 3 from first and the second. It will be 0 omega to the power 2n minus omega to the power n omega to the power n minus 1 again 0 1 minus omega n to the power n omega to the power 2n minus 1 will be 1 omega to the power n 1. We take common omega to the power n from here. We will have omega and we will take common omega n to the power minus 1 and we will have omega to the power n minus 1 plus omega to the power n minus omega to the power 2n. The determinant form will be 0 0 1 omega n 1 minus omega n omega to the power 2n minus 1 omega to the power n 1. Now if we calculate the determinant, we will have omega to the power n minus 1 plus omega to the power n plus omega to the power 2n. There it will be second bracket omega n omega 3n minus omega n minus 1 plus omega n. So omega n and omega minus n cancel each other. So we will have omega n minus 1 omega 3n. This is omega q is equal to 1. So omega q is equal to 1. We know that omega q is equal to 1. So omega 3n is equal to 1 to the power n is equal to 1. So this will be equal to 0. This term will be equal to 0. There we will get omega q 1 minus 1 0. This term will be 0 multiply 1 plus omega to the power n plus omega to the power 2n. This is equal to 0. So this is the value of the determinant, that it will be equal to 0. Since omega q is equal to 1, omega to the power 3n is equal to 1 to the power n, and it is equal to 1. So in this way you can solve this problem. And the another problem is given that find the value of the expression 1 by 1 plus 2 omega plus 1 by 2 plus omega minus 1 by 1 plus omega. So there, what we can do? Know that 1 plus omega is equal to minus omega square. So we can deduce this form in this way. This will be 1 plus omega plus omega. So this will be minus omega square plus omega plus 1 by 1 plus omega again will be minus omega square. This will be 1 minus omega square. 1 plus omega is equal to minus omega square. And this will be minus 1 by this will be omega square. From this you can look this that the LCM will be omega 1 minus omega square. 1 minus omega 1 minus omega and 1 minus omega square. This is the LCM. So if we take, we will have 1 minus omega square plus omega square omega minus omega square minus this will be omega square. It will be again. It will be omega square it will be 1 minus omega square and here it will be 1 minus omega. This will be the LCM actually. We will have omega 1 minus omega square. So we will have omega minus omega square and we will have 1 minus omega square and it will be omega square minus omega cube minus here it will be. We have to multiply both of these. This will be 1 minus omega square plus omega cube. So here omega square cancel each other. Omega cube will be 1. You know that omega cube is equal to 1. So we will have overall the numerator will be omega minus 1 minus omega square plus 1 omega cube equal to 1 and the denominator will be omega square 1 minus omega minus omega square plus omega cube. So plus 1 minus 1 cancel each other. Omega and omega cancel each other. This is minus. These both will be plus omega square plus omega square. It will be minus. We have to do it fresh. So we have the question. Take extra page. So here you see 1 by 1 plus 2 omega. Plus 1 by 2 plus omega. Minus 1 by 1 plus omega. And we have given that just we have to find out the expression of this. So let's take how we can calculate this. So we are given that 1 plus omega is equal to minus omega square. Omega q is equal to 1. So if we take the LCM of these three, one plus 2 omega plus 2 plus omega plus 1 plus omega. So here it will be 2 plus omega plus 2 omega plus omega square, which will be somewhat broad. 2 plus omega. This will be, or we can sort it by just replacing these values in this way. 1 by 1 minus, we are taking in this way 1 plus 1 minus omega square plus 1. So this will be omega minus omega square, omega minus omega square, and here it will be 1 minus omega square, and here it will be 1 by plus, it will be plus omega square, and minus omega square will be plus omega square. So it can be written down omega minus 1 minus omega. Here we can write down 1 by 1 plus omega, 1 minus omega square, 1 plus omega multiply 1 minus omega. And here it will be 1 by omega square. So the value will be omega square plus 1 plus omega, 1 minus omega. So the numerator will be for the first term omega 1 plus omega, that will be omega square, and here it will be 1 plus omega, 1 minus omega. So this will be omega plus omega square plus omega square plus 1 minus omega square, and then the denominator will be omega square 1 plus omega 1 minus omega. So these are cancel each other. So we have 1 plus omega square in the numerator, and the denominator is omega square 1 plus omega 1 minus omega. So this is equal to 0, So this time this expression is equal to 0.